Hello students, in this video I am going to discuss about finding domain of functions. Problem selected from the exercise for session 4 from Arihant Differential Calculus chapter functions. Solving problems from this exercise has been divided in 3 parts. In this video, that is in the first part, we are going to discuss about the first 7 sums from the same exercise. Those who have not seen the videos of solving the previous exercise from the same book, click the I button at the extreme right corner of your screen right now to view it, or else you can view it later on. I have given the link in the description box. Those who are new to this channel, subscribe it and press the bell icon to get notified about my new upload videos. Don't forget to like and share to those who need it the most. You can give me any suggestion in the comment box below. Let's start solving problems. In this problem, to define the function, we must write, since this expression is within the root sign, so it has to be greater than or equals to 0 to define the function. So from here we are getting x square can also be written as mod x whole square. Is it clear? After factorizing, we are getting mod x minus 2 into mod x plus 1 is greater than equals to 0. So now from the number line we can get this first condition is impossible because mod x is always greater than 0. So from this we are not going to get any real values of x which satisfies that mod x is less than equals to minus 1, right? So the only possibility is that your mod x is greater than equals to 2. Mod x is greater than equals to 2 implies either x is greater than equals to 2 or x is less than equals to minus 2. Therefore, the required domain is x belongs to minus infinity to minus 2 closed or close to infinity. Is it clear to all of you? Let us move for the next problem. In this function, if we want to define the expression which is within the root sign has to be greater than or equals to 0. So the conditions are 2 minus mod x has to be greater than equals to 0 and 1 plus mod x has to be greater than equals to 0. Now 1 plus mod x is greater than equals to 0 is true for all x belongs to real value. As mod x is always positive, so when you add 1 with that any positive number, it will always give you greater than equals to 0. Is it clear? But from the first one we can say mod x is less than equals to 2. Mod x is less than equals to 2 implies x lies between minus 2 and 2. Is it clear? Therefore, the required domain is the common region between this and this, which is obviously x belongs to minus 2 to 2, and this is the required domain for this given function. Is it clear? Move for the next problem. In this problem, to define the function, your x has to be greater than 0. Now, one thing you observe, the given function is this. The first condition is that your mod of x base e has to be greater than 0 because this expression is within a log, right? It has to be greater than 0. Now, obviously, mod of log x base e is always greater than 0. Is it clear? Because mod means the positive value of that logarithm, which is always greater than 0, right? Now the question comes, if x becomes 1, your log x base c, which is nothing but your 0, which is very much defined. But in this case, it will not be defined because if log x becomes 0, then your function will become which is undefined. Is it clear? Therefore, the required domain will be x is greater than 0 except 1. You can write it in this form also. Is it clear? Otherwise, you can write it in this form also. That's it. That's your domain for this function. Is it clear to all of you? Move for the next problem. In this function, if we want to define it, sine inverse x, we all know that for sine inverse x, x always lies between -1 and 1. Therefore, from here we are getting is it clear? So your box x is lying between -2/3 to 2. Now as box x is an integer, so between these values, the integers that we are getting are 0, 1 and 2. Is it clear? Now when box x is 0, x lies between 0 and 1. When box x is 1, x lies between 1 and 2. When box x is 2, x lies between 2 and 3. Therefore, the required domain for this function is x belongs to close 0, open 3. That's it. Have you understood it? Okay, let us move for the next problem. In this function, we are having log fractional part of x, because we know that x can be written as box x plus fractional part of x, right? Therefore, the given function is nothing but log of fractional part of x. Now, to define the function, your fractional part of x has to be greater than 0. Now, we all know that fractional part of x always lies between 0 and 1. But one thing, your fractional part of x cannot be equals to 0 in this case. Therefore, fractional part of x is greater than 0. It is true for all real values of x except the integers. Is it clear to you or not? Because if x is integer, then fractional part of x becomes 0, which will not satisfy this condition. Therefore, the required domain is x belongs to any real value except all the integers. Is it clear? Let us move for the next problem. In this function, to define it, the expression within the root sign has to be greater than 0. It cannot be equals to, because if it becomes equals to 0, then your fx will become undefined. So from here, after factorizing, we are getting, again from the number line we can say, now from the first one, look it carefully, your greatest integer function is greater than 3. It means box x will take the first value as 4, 5, 6 and so on. Now when box x is 4, we can say that x belongs to 4 to 5. Is it clear? When box x is 5, your x belongs to 5 to 6. When box x is 6, your x belongs to 6 to 7 and so on. Therefore, we can write from here x belongs to closed 4 to infinity. Is it clear to all of you? Okay, see this part, your greatest integer function is less than -2. So the first value that box x or the greatest integer value of x can take is nothing but -3, -4, then -5 and so on. When box x is -3, x belongs to, when box x is -4, x belongs to, and so on. Therefore, from here we can write x belongs to -infinity to -2 open. Therefore, the required domain is it clear to everybody? Have you understood it? Okay. Let us move for the next problem. In this problem, to define the function, we know that for cosec inverse x, your x has to be, mod x has to be greater than equals to 1. That implies either x is greater than equals to 1 or x is less than equals to minus 1. No values can be taken between minus 1 and 1 for cosec inverse x. That is the domain for the function cosec inverse x, right? Now, to define this function, we must say that box of 1 plus sine square x, either it has to be greater than equals to 1 or less than equals to minus 1. Okay? Now, we all know that greatest integer function of x plus any integer can be written as box of x plus integer. So, from the first one, we can say, is it clear? Absolutely. Now, you observe your sine square x, it can take three kinds of value. Number one, sine square x can be 0. It can be any value lying between 0 and 1, or it can be 1. When sine square x is 0, then box of sine square x is also equals to 0. Now, sine square x, when box of sine square x is 0, this condition is satisfying. Tell me yes or no. Now, when sine square x is lying between 0 and 1, in that case also your box of sine square x will be equals to 0. Then also it is satisfying this condition. And when box of sine square x is equals to 1, then this condition becomes 1 plus 1, which is equals to 2, which is again greater than equals to 1. Therefore, from this condition, we can say that your x can belongs to any real value. Is it clear? Now, let us come for the second part. Now, this condition is not true under any circumstances. Why? Because again, sine square x can take the value either 0 or between 0 to 1 or 1. Now, in all the cases, if you consider your value of 1 plus box of sine square x will never be less than equals to minus 1. Is it clear? Therefore, the domain will be determined from the first condition only, and the domain of the function in this case will be x belongs to any real value. Have you understood it clearly? Okay.